Dear student, welcome to the lecture series of nanotechnology and material science. Today we are covering one of the special topic about the material surface characterization, and that topic is known as Auger electron spectroscopy. Auger electron spectroscopy is a type of technique which determine the presence of amount of a material and as well as the element. So this means that Auger electron spectroscopy is a technique which tell us about the composition and element present on the surface of material. Dear student, please note that the penetration depth from which Auger electrons are produced is in the range of 3 to 10 nanometer. So you can Auger electron spectroscopy can only give us information in the range of 3 to 10 nanometer. So in a simple word, Auger electron spectroscopy is defined as Auger electron spectroscopy is an electron beam sensitive analytical technique which provide us information about composition and element in a near surface environment of material, typically in the range of 1 to 5 atomic monolayer or in depth 3 to 10 nanometer using Auger electron. So in a simple word, Auger electron spectroscopy is an electron beam surface sensitive technique. On the basis of this technique, we can give information about the composition and as well as element present near the surface of material in the range of 1 to 5 atomic monolayer or 3 to 10 nanometer depth. However, the average penetration depth in Auger electron spectroscopy is 5 nanometer. Now question here arises that why Auger electron spectroscopy can give us information in the range of 3 to 10 nanometer. Why we cannot get Auger electron below the penetration depth or below the 10 nanometer. Dear student, please note that the energy of Auger electron is in the range of 50 electron volt to 3 kilo electron volt. So for this energy, 350 electron volt to 3 kilo electron volt, the mean free path is very short, which means that Auger electron cannot go beyond this penetration depth. The mean free path is short. This means that the average distance between the collision of Auger electron become too short, which as a result will basically cause the decrease in penetration depth, and that's the reason the Auger electron are only emitted from the surface of the material in the range of 5 nanometer, average thickness of 5 nanometer. So when these Auger electrons are emitted, then the intensity and peak of position of the Auger electron is recorded by detector, and on the basis of this the intensity give us the information of the composition and amount of material present, whereas the peak position will give us information about the various types of element present in the surface of the material in a penetration depth of 3 to 10 nanometer. So as a whole, Auger electron spectroscopy give us information about the composition and as well as the presence of an element in the range of 3 to 10 nanometer of thickness of material. Dear student, in order to discuss the Auger electron spectroscopy, it is very important to understand the interaction of the electron beam with a matter. How the electron beam interact with a matter. Electron beam interact with the matter may cause a reflection of the electrons from the sample surface. Electron beam, when interact with a matter, it may cause an emission of tertiary or secondary electron from the sample surface. The electron beam interact with a metal surface may cause an absorption of the incident beam of electron inside the sample. The electron beam may cause the transmission of electrons from, and they may be transmitted from the sample. So dear student, on the basis of interaction of the electron beam with a material surface and on the basis of emission, transmission, absorption and reflection of electrons from the sample or from this material surface, different types of advanced techniques are introduced in material science and engineering. Some of the common techniques are known as scanning electron microscopy, transmission electron microscopy, Auger electron microscopy, etc., or Auger electron spectroscopy, etc. So there are diverse type of techniques which are introduced on the basis of electron beam interaction with a matter surface. Auger electrons are also produced due to electron beam interaction with a matter surface. So in order to understand Auger electron in depth, it is very important to understand the interaction of electron beam with matter. So dear student, the interaction of electron beam with a matter surface take place in a different ways. Let us discuss about the reflection which is caused by an incident of highly energetic beam of electron from a matter surface. Consider this schematic representation of a sample or a specimen. So when the electron beam, a highly energetic electron beam like this is interacted, then due to the interaction of this highly energetic beam of electron with a surface of a specimen, it will result into a reflection or removal of another electron from the sample surface. The removed electron, due to an interaction of highly energetic beam or stream of electron, is known as secondary electron. This may be represented like this. Consider this as an electron beam which is interacting with a small portion of the sample surface. So basically the electron beam is transferring a huge amount of energy to the sample surface. And if the incident beam or stream of electron has a higher energy than the binding energy of any electron present on the sample surface, then that electron, due to an incidence of a stream of beam of electron, will be ejected from the sample surface, and that electron is basically known as secondary electron, and the process is known as a reflection process. So when the stream of the beam of an electron is incident on the sample surface, there will be any additional electron, or there will be an electron present on the surface of the sample. Then due to transfer of the energy of this stream or beam of electron to these electrons with less binding energy, this electron will be ejected from the sample surface like this. And this process is basically known as reflection process of electron. So basically, dear student, the energetic beam of electron with a matter or with a sample or with a specimen surface may cause a reflection of other electrons present on the sample surface. The reflections of the other electron from the sample surface may be represented by a schematic diagram of a sodium atom like this. Consider this as a schematic representation of a sodium atom which have total number of 11 electron. K shell has 2 electron, L shell has 8 electron, whereas M shell, which is a balanced shell of a sodium, has a 1 electron. So now let's discuss the phenomenon of reflection in a sodium atom due to an incident beam of an electron. Consider this as a stream of an incident beam of electron. So now when the stream of incident beam of electron, which if have a higher energy than the binding energy of the electron like this present in a sodium atom, then this electron, the energy of the stream of beam of electron will be transferred into the sodium electron present in an orbit, or in a shell, will be ejected from an atom. So now like this is an electron. Okay, this electron fall on the electron present in the L shell. So the electron, if the energy of the incident beam of the electron is higher than the binding energy of this electron, then due to this, the electron will be ejected from the sodium atom. So this ejection of the secondary or additional electron from the any shell of an atom is basically caused due to a reflection. Now, dear student, this is a schematic of a reflection of an atom from a sample surface, a reflection of electron from a sample surface due to a high beam of energetic stream of an electron. So these reflected electron from the sample play very important role. You can have an information about the surface of the material like morphology, topography, and even you can have an information about elements and as well as composition present on the surface of the matter, on this or the surface of the sample, or on the surface of the specimen. So these secondary electrons which are ejected from the sample surface due to reflection are used in different characterization technique in order to assess the sample surface. One of the most commonly used technique is known as scanning electron microscopy. Scanning electron microscopy is a technique which is based on secondary electron emission. Secondary electron emissions are generated due to an incidence of a beam of highly energetic electrons, and these beam of incident highly energetic electron basically cause reflection of an electron from the sample surface, or reflection of the secondary, or reflection of second electron from the target surface. And these, on the basis of the reflected electron from the target surface, you get an information about a morphology, about a topography, about a density of the material, even about the composition of the material, and as well as element analysis by using scanning electron microscopy. So dear student, scanning electron microscopy is a type of electron microscopy which is designed to directly study the surface of a solid object. Usually it is used for solid object, but please note that it is may be used in for polymers and as well as different types of other materials, but the usually the scanning electron microscopy is used to study the surface of the solid object. And this technique basically utilized an electron beam which is focused on the surface of the sample. And when the electron beam is focused on the surface of the sample, that electron beam basically causes a reflection of the electron from the sample surface. And those reflected electrons are basically detected in a detector, and on the basis of that we study about the morphology and as well as topography of a material. Student, please note that usually the scanning electron microscopy has a resolution around 2 nanometers, and you can basically analyze the features on the sample even lower than that, but it depends on the SIM or scanning electron microscopy which you are using in a lab. So one of the most important technique which is a core of material science, it is a scanning electron microscopy, which basically gives you information about the surface of the material, about the topography of the material, about even about the composition of material if you are the system is connected with XRF. And you can also do elemental analysis with scanning electron microscopy. So all the wealth of information which you achieve from the scanning electron microscopy are based on secondary electron information, and these secondary electrons are basically produced by a reflection process due to an incident of an electron beam. Another important technique which is based on reflection of electrons is known as low energy electron diffraction. So the student, low energy electron beam diffraction is very important technique which is used to get information usually about a structure of single crystal. So this technique is also based on the reflection of the electron from a specimen surface. So in low energy electron beam diffraction process, usually a low energy electron beam of around 30 to 200 electron volt is incident on a matter surface or on a single crystal surface. This low energy beam electron basically causes a diffraction of another electron. And on the basis of the observation of the diffractions of electron on as spots on a fluorescent screen, which is used in a lead, give us an information about the structure of a single crystal. So in a simple word, lead is a technique which is based on reflection process, which is caused due to a stream or due to an electron beam. Another most commonly used technique is known as high energy electron diffraction technique. It is also known as heat. So a heat technique is based on an interaction of highly energetic electron beam with a matter surface. The student, a high energy electron beam technique is also known as READ, which means reflection high energy electron diffraction. This is very important technique in order to study the structure of the material. So that technique is also based on the reflection of an electron from sample surface. And voltage contrast can also give you information about the surface electronic properties, and this is also based on reflection of a secondary electron from a metal or from a specimen surface. So all these techniques, scanning electron microscopy, which is a core of material science and engineering, low energy electron diffraction and high energy electron diffraction, which is a core of semiconducting industry, and similarly voltage contrast techniques, all those techniques are based on a reflection of a secondary electron from a matter surface. The interaction of the highly energetic beam of electron may cause a transmission of the electron from the sample surface. Please note that usually transmission of electron is done at higher accelerating energy of the electron. Accelerating energy of electron is usually around 100 to 300 and even up to 400 kilovolts. And due to a highly energy of the incident beam of electron, the electron will pass through the sample surface. Consider this as a schematic representation of a sample surface. When an incident beam of highly energetic stream of electron incident on a sample surface like this, the electrons will be transmitted from the sample like this. They will pass through the sample because of the very high energy of the incident beam of electron. So these transmitted electrons, basically the energy vary when they pass through the specimen material or when they pass through the sample. And this variation of the energy of the transmitted electron basically give us very important information about the structure, about the chemical composition, and even about the crystallographic orientation of the material present in a sample. So in a simple word, the interaction of the electron beam with a matter surface or with a specimen may cause a transmission of the incident beam of electron from the sample surface with a different energy. These transmitted beam or a stream of electron are collected by a detector, and on the basis of that, structure, morphology, composition, orientation of the material is determined. So there are different techniques available in material science which are based on transmission of electron from a matter surface or from a sample surface. One of the most commonly used technique of the material science and engineering industry is known as transmission electron microscopy. Transmission electron microscopy is very important technique. This technique gives you information about the structure of the material, about the composition of the material, about the crystallographic orientation in the material. So this technique basically use an ultra thin material. If I define the transmission electron microscopy technique, transmission electron microscopy is a technique in which a beam of electrons is transmitted through a specimen, and the transmitted beam of electron basically provide an image of a variation of energy of an incident and after the transmission. This variation of energy basically gives you an information about the structure, composition, and as well as orientation of the material present in a material. Secondly, the student, please note that the transmission electron microscopy use a specimen which is very ultra thin. Its thickness is around 100 nanometer. So a very ultra thin section less than 100 nanometer thick is used, or a suspension may be used on a grid. So this means that TEM basically use an ultra thin material. A material or a specimen is made ultra thin because the more the thin is the material, it will be easy for the electron beam to be transmitted from the material, and you can basically get an image with a higher resolution. Dear student, please note that the accelerating voltage or the energy of the incident beam of electron is quite high in transmission electron microscopy. Around 100 kilovolt to 300 kilovolts is used to accelerate the incident stream or beam of electron to pass through the specimen or material surface in transmission electron, pass through the specimen in a transmission electron microscopy. The TEM is basically a magnificent technique because this technique provide information about the surface features, about the shape, size and structure of the sample or a specimen through which it is passed. And though the drawback with the TEM is that we need a high energy setup, so high potential is used in TEM. Another drawback in TEM is that the chamber of TEM is usually under a very high vacuum, so lot of cost is basically used to do a TEM analysis. So in simple word, the difference between TEM and SEM is a reflection and a transmission of electron. SEM, or secondary electron microscope, or scanning electron microscope, use a reflected electron, whereas transmission electron microscope use a transmitted electron. This is a core difference. Second is that the resolution of TEM is quite high than the scanning electron microscopy. Okay, so another technique which is based on a transmission of electron is known as electron energy loss spectrum. Listen, please note that electron energy loss technique is usually based on transmission. This technique basically gives us about the information of what is a chemical composition present in a material. So on the basis of a transmission of electron from a matter surface, if we use yield or electron energy loss spectroscopy technique, we basically get an information about the chemical composition of a specimen. Dear student, please note that it is not necessary that every time when electron incident on a sample surface is reflected or it is transmitted, there is a possibility of a stream of electron when they incident on a sample surface. That stream of electron may be absorbed by the sample surface. Okay, so absorption is also possible in infraction of an electron beam with a matter or with a specimen surface. Consider this as a schematic representation of a sample. This is a highly energetic incident beam or stream of electrons. So when the electron or stream of electron incident on a sample surface, there is a possibility of absorption of electron on the sample or inside the sample. These absorbed electrons are also used in order to study the electronic and electrical properties of the sample. So basically the absorbed electron in a sample or in a matter due to an interaction of energetic beam of electron basically can give you an information about the electrical and electronic properties of the matter. One of the most commonly used technique which gives you an information about the electrical and electronic properties of a material is known as electron beam induced current. So electron beam induced current is a technique which is used for analyzing an electrical properties of a sample. Usually this technique is most commonly used for a semiconductor materials. So on semiconductor material, an electron beam is fall and the beam is, if the beam is absorbed in the sample surface or inside the sample, the current generated by the sample is basically analyzed by electron beam induced current technique. So on the basis of that, the electrical and electronic properties of the semiconductor material is determined. Please note that this absorption of the electron is usually observed in scanning electron microscopy also. Basically, the electron beam induced technique is present or is equipped or is inside scanning electron microscopy. With that, basically, the absorption of the incident electron beam which cause a current is measured. So they are also a part of the scanning electron microscopy. Dear student, apart from reflection, transmission and absorption, the incident electron beam may cause an emission, either the emission of another tertiary electrons from the sample surface, or the incident beam may cause an emission of different types of rays like X-rays, etc. So in interaction of electron beam with the matter, that interacted electron beam may cause an emission in the form of electromagnetic radiation or emission in the form of tertiary electrons. So consider the emission of the electron or a stream of energy from the surface of the material due to incidence of an electron beam or stream of electron beam. Consider this as a sample. So when a beam of electron like this is incident on a sample surface, if the energy of the beam of the electron is too high, then this beam of electron will cause an emission, either the emission of an electron or emission of the electromagnetic spectrums like X-rays, etc. Now let us discuss the emission of tertiary or Auger electron from the sample surface. Student, please note that the emission, the removal of the Auger electron from the sample surface is based on emission, which is caused by the incident stream or beam of electrons. Consider an atom. When high energetic beam of electron like this stream of light is incident on core shell of an electron present in a core K shell of an atom, if the energy of the incident beam of electron is higher than the binding energy of the core shell electron, then this core shell electron will be emitted from an atom. Now this atom become unstable because atom has only one electron in core K shell. In order to stabilize the atom, electron from higher shell or higher energy level like L energy level will jump into vacant position of the core K shell. And when this electron jump from higher K level into lower energy, from higher L energy level into a K energy level, this electron will emit the extra energy during the transition from higher energy level into a low energy level like this. The transmitted energy will be K alpha X rays. Okay, and this transmitted energy or the energy is basically, it is an emitted energy, and this emitted K alpha X rays basically will eject an electron due to a process of an emission. Okay, this ejected electron is known as Auger electron. So students, in emission process, a sample is interacted with electromagnetic radiation or with highly energetic beam of electron like this. When the sample interact with a high beam of electron, additional electron if present in a sample, or tertiary electron present in a sample, or electromagnetic radiation in a sample will be generated due to an interaction of the highly energetic stream of electron, and the ejected beam or tertiary electron or a beam or a spectrum of energy electromagnetic radiation like X-rays is due to a process of emission. So this emission process is beam of electrons or these emitted electromagnetic radiations or stream of electron are used to study the property of the material. One of the most commonly used technique which is based on emission of electron is known as Auger Electron Spectroscopy. Auger Electron Spectroscopy is a technique which is based on elemental and compositional analysis of the material. So with this technique, we basically assess the composition and as well as the presence of element in a material. The depth of a sample through which an Auger electron may be emitted is in the range of 3 to 10 nanometer. So emission of the Auger electron depth depend on the nature of the material. However, the average penetration depth of sample from which Auger electrons are emitted is around 5 nanometer. Another technique which is based on emission of the electron is known as cathodoluminescence. So cathodoluminescence is basically caused due to emission of the electromagnetic radiation. Okay, Auger electron is based on emission of the electrons, whereas cathodoluminescence is based on emission of the electromagnetic radiation or emission of the light due to interaction of the electron beam with a matter. Students, please note that cathodoluminescence microscopy is a technique which basically gives us information about the sample. Cathodoluminescence microscopy is a term used to describe the analysis of the light emitted from the sample in electron microscope. The light may be, this emitted light in cathodoluminescence may be ultraviolet, visible and infrared wavelength portion of the electromagnetic spectrum. So basically, the cathodoluminescence microscopy or cathodoluminescence microscope basically analyze the emitted light due to incidence of the electromagnetic radiation. The emitted light basically gives us some basic information about the material. Another technique which is based on the emission of the electron or electromagnetic radiation is known as electron microprobe. Okay, so electron microprobe is based on emission of the emission of the tertiary electron or electromagnetic radiation. Then please note that electron microprobe technique is also a part of scanning electron microscopy. It is also used in scanning electron microscopy. But the core function of electron microscope is that this technique is non-destructive technique, which basically give you the information about the chemical composition of small volume of usually of a solid material due to a process of emission of the radiation from the solid surface or from the sample surface. So in a simple word, an electron microscope which is known as a microprobe which is known as electron probe microanalyzer or electron microprobe analyzer is an analytical technique which is based on emission of the electron or electromagnetic radiation used non-destructively to determine the composition of a small volume of a sample surface. So dear students, this is just an overview of an interaction of an electron beam with a metal surface, and what are the possible techniques which are based on emitted, transmitted, absorbed, or reflected electrons or electromagnetic radiation due to interaction of the energetic electron beams. So if I summarize, the energetic electron beam when interact with a matter, that electron beam may cause reflection. The incident electron beam may cause transmission. Incident electron beam may cause absorption. Incident electron beam may cause emission of the additional electron or electromagnetic radiation from a sample surface. On the basis of reflection, transmission, absorption, and emission of the electromagnetic radiations or additional electrons from the sample surface, different assessment about the chemical composition, about the structure of the material, about elemental analysis of material is done by using different characterization techniques like scanning electron microscopy, transmission electron microscopy, Auger electron microscopy, cathodoluminescence, electron microprobe technique, etc. So this is just an overview of interaction of the electron beam with a metal surface. Now we can easily explain that how Auger electron are produced from the sample surface and how the Auger electron may be used in order to analyze the elemental and chemical composition of the material. So basically the interaction of the electron beam with a matter surface give us the diversity of the techniques which are possible. So our lecture will be, since our lecture is about Auger electron spectroscopy, so onward we will discuss about it, how the Auger electron spectroscopy is used, what are the limitations of the Auger electron spectroscopy, how Auger electron is produced, and how the Auger electron is assessed in Auger electron microscopy for elemental and compositional analysis. Now students, since I have briefly explained the different types of interaction which basically electron beam do with a sample surface, and on the basis of interaction there may be a reflection, there may be an emission, there may be absorption or transmission of the electron beam. So you have understand that what kind of techniques may be used on the basis of the interaction, and what kind of analysis may be done on the basis of the emission, transmission, reflection, or absorption of electrons. So now it is quite easy for you to understand the Auger electron spectroscopy. Auger electrons were observed by a French nuclear and particle physicist Pierre Auger in 1920. And then these observed electrons were used, and a technique was known as Auger electron spectroscopy was developed in 1960. So dear student, in a simple word, Auger electron spectroscopy is a surface sensitive analytical method which provide compositional and as well as in elemental information in the near surface environment of material, typically in 1 to 5 atomic layers or 3 to 10 nanometer depth using Auger electron. So in a simple word, Auger electron spectroscopy is a surface sensitive analytical technique which is used to give the compositional and as well as elemental information of material near its surface in the range of 1 to 5 atomic units or in the range of 3 to 10 nanometer thickness by using Auger electron. So this means that Auger electron spectroscopy is limited to a certain depth. The average depth from which an Auger electron from the surface may be ejected is around 5 nanometer. However, the depth of emission of Auger electron varies from materials to material, and it is in the range of 3 to 10 nanometer as a whole. So with this technique, the Auger electron are basically ejected from 3 to 10 nanometer, which is detected by detector and on the basis of the intensity and variation of energy of ejected Auger electron, you can basically analyze the composition and as well as the presence of different element in the material. Distant Auger electron spectroscopy is very surface sensitive because the Auger electron has energy in the range of 50 electron volt to 3 kilo electron volt. This means that due to this energy range, the Auger electron has a shorter mean free path, which means that Auger electron, the distance between the average Auger electron is very short and they may collide. So as a result, the penetration depth or the depth from which Auger electron will be released from the material will be less, because the electron get vanished when they collide, and at the end you will get less Auger electrons. So which means that the Auger electron are limited to a very small or very few nanometer of the surface of the material. So Auger electron spectroscopy is a surface sensitive technique, and surface sensitivity in Auger electron arises from the fact that emitted Auger electrons have usually an energy in the range of 50 electron volt to 3 kilo electron volt, and at these values electrons have a short mean free path in a solid. The escape depth of electron is therefore localized to a few nanometers of the target surface, which giving that Auger electron is an extremely sensitive to a surface species. So in a simple word, if I conclude, Auger electron is a surface sensitive technique because the energy of the emitted Auger electron is in the range of 50 electron volt to 3 kilo electron volt, which means that the mean free path is for Auger electron is short, and as a result an Auger electron will be emitted from few nanometer depth of the surface of the material or thin films. Students, please note that X-rays photoelectron spectroscopy is also a technique to determine the elemental and as well as chemical composition of the material. So both the function of Auger electron spectroscopy and as well as X-rays photoelectron spectroscopy is same. Both are used for elemental and as well as chemical composition of the material surface. The main difference between X-rays photoelectron spectroscopy and Auger electron spectroscopy is that Auger electron spectroscopy use X-rays or photons for the emission of the core electron in an atom, whereas in Auger electron spectroscopy a beam of electron is used to emit the Auger electron from an atom. So XPS and Auger electron spectroscopy are somehow same, but the XPS use the X-rays beam to eject an electron, while Auger electron spectroscopy uses an electron beam to eject Auger electron. Dear students, since the energy of the Auger electron is in the range of 50 electron volt to 3 kilo electron volt, so this means that the mean free path of Auger electron is very short. This short mean free path of Auger electron limit the Auger electron detections from the surface of material. The detection limit of Auger electron is in the range of 0.1 to 1% of a monolayer. And whereas the material used during Auger electron spectroscopy is around 10 to the power minus 16 to 10 to the power minus 15 gram, and whereas the volume used in Auger electron spectroscopy is around 10 to the power 12 to 10 to the power 13 atoms per centimeter square. So this means that Auger electron spectroscopy used very small material, and basically it interact, or these are produced from a very small portion of the material which is under analysis. Only 10 to the power minus 16 to 10 to the power minus 16 gram of material with a volume of around 10 to the power 12 to 10 to the power 13 atom per centimeter square material basically produce the Auger electron from the whole surface of the material. So this means that Auger electron spectroscopy has a limit in detection. It can basically, they are basically ejected from a very small portion of the material, which is in the range of 10 to the minus 16 gram to 10 to the power minus 15 gram, and whereas the volume of the material is around 10 to the power 12 to 10 to the power 13 atoms per centimeter square. Dear student, in order to understand the Auger electron spectroscopy for compositional and elemental analysis, it is very important to understand what is Auger electron, how an Auger electron is emitted from atom, and then it is detected by a detector in Auger electron spectroscopy in order to investigate elemental and compositional analysis of material. So how Auger electron is produced or is emitted from an atom? Consider the Auger electron emission from sodium atom. Sodium atom or any atom consists of a nucleus. Nucleus is a combination of proton and neutron. Proton are positively charged, whereas neutron have no charge. Dear student, please note that nucleus also constitute subnuclear particles like bosons, antineutrons, etc. But for simplicity, usually we consider that a nucleus consists of a positively charged particle known as proton and negative a chargeless particle neutrons. So we here are giving the example of sodium atom. So the nucleus of the sodium atom will have 11 proton because the atomic number of the sodium is 11. This means that the number of proton or electron in sodium atom will be 11. So 11 protons are present in sodium nucleus. Every nucleus in atom has energy level around it. The energy levels around the nucleus are known as shells, and electrons revolve around the nucleus in those energy levels. So the first energy level around the nucleus is known as K shell. Dear student, please note that every shell is divided into subshells. K shell is a first shell or first energy level around the nucleus. So the K shell has one subshell and that subshell is 1s2. 1 represents first shell, S2 is subshell, S represents subshell, and 2 represent the maximum number of electrons possible in S shell, in S subshell. So dear student, in a simple word, K shell around a nucleus has 2 electrons. The second shell around the nucleus is known as L shell. L shell is further divided into 2 subshells. These subshells are 2s2, 2p6 subshells. 2s2 subshells mean 2 mean second shell and S is a subshell and 2 represent the number of electrons. So 2s2 subshell has 2 electron, and whereas 2p6 subshell in L shell has 6 electron. So as a whole, L shell around the nucleus of an atom has maximum number of 8 electrons, like this. Since we are representing Auger electron emission from sodium atom, so the atomic number of sodium is 11. Nucleus has 11 proton. Similarly, the electron in the energy level around the nucleus will be 11. So the maximum number of possible electron in sodium atom will be 11. K and L shell already have 11 electrons. So the next shell around the nucleus is known as M shell, and since the K and L shell have 10 electrons, so only 1 electron will be present in the M shell. Dear student, please note that as a whole, M shell in atom is divided into 3 subshells. These subshells are 3s2, 3p6 and 3d10. 3s2, 3 represent third shell. S is a subshell and S2 represent number of electron. So 3s2 subshell have maximum 2 electron. 3p6 subshell of atom have maximum 6 electron, and 3d10 subshell have maximum 10 electron. So however, in sodium atom, the K and L shell have 10 electrons, so only one electron left, and that electron will be present in M shell. Okay, the electron present in M shell of sodium atom is known as valence electron, whereas the shell M shell in a sodium is known as valence shell. Now let's discuss the emission of Auger electron from sodium atom. Auger electron are produced when high energetic beam of electron incident on the core shell electron like K shell electrons. So considered, this is just an atomic representation that how the electron revolve around the nucleus of an atom. So now consider the energetic beam of incident electron. This represents that the energetic beam or stream of the electron, they incident on the electron which is present in core K shell. Now the student, please note that electron which are revolving around the nucleus in K, L and M shell basically have energy levels, have energy in K, L and M shells. Due to this, the electron revolve around the nucleus. The energy between the nucleus and electron bind the electron with a nucleus, and that energy is known as binding energy or nuclear attraction energies. Okay, so every electron in K energy level or M energy level or N energy level have a specific binding energy with a nucleus. Now the energetic beam of incident stream of electron will fall on an electron present in core shell if the energy of this energetic beam of electron nu is higher than the binding energy of this core electron, then this core electron will be ejected from the atom. So as a result, this black curve you can see will be created in core shell. Now dear student, please note that the K shell of the sodium atom has only one electron because another electron in the core K shell is ejected by the incident stream of the electron. So this means that the sodium atom as a whole become unstable because the core shell is empty or core shell has only one electron. So in order to make the core shell or in order to make the sodium atom stable, the electron from higher energy level like L shell will jump into lower core energy level K shell. Student, please note that the electron at higher energy level have higher energy as compared to the electron present in a core shell or lower energy level. So when electron from higher energy level like K energy level jump into a core like L energy level jump into a core K energy level, then electron due to higher energy level will release some amount of energy in the form of characteristic X-rays. like this. Okay, so this is basically characteristic X-rays, K alpha X-rays, which is basically generated due to a jump of a higher energy level electron into a core vacant position of the core K shell. So when the K alpha is released, or characteristic X-ray is released due to this transition from higher energy level into a core K shell energy level, if the energy of the K alpha radiation is higher than the binding energy of the electron in atom, if the characteristic K alpha X-ray energy is higher than the binding energy of this electron with the nucleus, then when this characteristic X-ray interacts with such electron, then that electron will be ejected or will be emitted or will be removed from the shell of an atom. When the electron is removed or emitted from the atom due to characteristic X-rays, such electrons are known as Auger electron. So dear student, the effect of emission of Auger electron is known as Auger electron effect. The process through which the Auger electron are emitted is known as Auger electron process. So this ejected electron from atom is basically used in Auger electron spectroscopy for compositional and elemental analysis. Now the student, question here is that how someone can determine that the electron, let's say emitted from Auger electron emitted from sodium is an Auger electron of the sodium. How you can determine in Auger electron spectroscopy? This is quite simple, dear student. Every electron in K, L and M shell have a different nuclear attraction forces or have a binding force with a nucleus in their shells. Okay, like sodium has 11 electrons, so the K shell or core shell electron will have a binding energy, but this will be less than any element which have a higher atomic number. Okay, like tungsten, it has a higher atomic number than sodium. Okay, so it will have more number of protons and more number of electrons. So the core K shell, although of the tungsten atom, will have 2 electrons. Okay, but the binding energy of the tungsten K shell electron will be very much stronger than the sodium atom, because sodium has 11 protons. So the interaction of the 11 protons with an electron present in a first shell will be less than the atom which have a higher number of the proton presence. So on the basis of this, the ejected Auger electron will have different intensities and different potential. On the basis of that, basically elemental and compositional analysis of the material is determined. So if I simply conclude that how Auger electron is produced in Auger electron spectroscopy, usually in Auger electron spectroscopy, a beam of electron is incident on an atom. Okay, when the beam of incident electron is incident on a core shell electron, if the incident energy of the beam of electron is higher than the binding energy of the core electron, then the core electron will be ejected, will be emitted from atom. So the atom will become unstable. In order to make the atom stable, electron from higher energy level will jump into the core shell electron vacant position. So when the higher energy level electron jump into a vacancy of the core shell electron, then the higher energy electron will emit characteristic X-rays. If the energy of the emitted characteristic X-rays is higher when it's incident on another electron, and if the binding energy of that another electron like this is less than the energy of the characteristic X-rays, then this electron will be emitted in a form of Auger electron. So this Auger electron is basically analyzed by different types of detector present in Auger electron spectroscopy, and on the basis of that, chemical and as well as compositional and elemental analysis of the material is determined. So now, dear student, let us discuss that how Auger process take place in Auger electron spectroscopy. Student, please note that Auger electron spectroscopy technique use electron gun. Electron gun is a device which used to liberate or emit the highly energetic electrons. And the energy of the emitted electron is in a range of 3 to 30 kilo electron volt. So in Auger electron spectroscopy, an electron gun is used which have an energy of emitted electron in the range of 3 to 30 kilo electron volt. So when electron beam with sufficient energy is incident on an atom, eject a core electron and create a vacancy. So in Auger electron spectroscopy, an energetic electron beam with energy of 3 to 30 kilo electron volt is incident on an atom, on an electron of an atom which is present in a core shell. And the energy, since the energy of the incident beam of electron is quite high than the core shell electron binding energy, which will in a result cause the ejection or removal of the core shell electron, and as a result vacancy will be created in atomic structure and the structure will become destabilized, which can be represented by atomic structure like this. An atom have a nucleus. Consider a sodium atom again. It has a K energy level with 2 electron, L energy level of shell having 8 electron, and M energy level with 1 electron. Okay, now the beam of the electrons, since the electrons revolve around the nucleus, now the beam of the highly energetic stream of electron which are produced from the electron gun, when they incident or when they fall on the electron of the core energy level, since the energy of the beam of electron is 3 to 30 kilo electron volt, which is too much. So when it fall on electron of the core shell, then this beam of electron will eject the core shell electron, and as a result vacancy will be created. Now, the secondary electron of higher energy level or shell will jump or drop down to fill the vacancy. Since the lower energy level electron or core energy level electron is ejected or is removed by the incident high energy beam of electron from the electron gun. So this ejected electron create a vacancy in a core K shell. So the secondary electron which is present at higher energy level like L shell will jump into a core energy level to fill the vacancy and to make the structure stable. This will be represented like this. So incident electron beam is fall on a core shell electron, which as a result emit or eject the core shell electron from K shell of an atom, and it remove it from also from an atom. So the vacancy is created. Now this L shell electron have a higher energy will jump into the vacant position of the K shell electron like this. Okay, so the structure of the atom will become stable in K shell because the higher energy level electron have jumped into a lower energy vacant position of the K shell electron. So when when the secondary electron is basically jump from higher energy level into a low energy level K shell, the secondary electron will emit sufficient characteristic X-rays. It will emit highly energetic characteristic X-rays from higher energy level due to transition from higher energy level into a lower K core shell. So this, if the characteristic X-rays energy is higher than any other electron present in higher energy levels or shells, then the characteristic X-rays will eject that tertiary or that third one electron from the higher energy level, and such electron is known as OJ electron. This can be presented like this. Consider this is the electron beam which is incident on an core shell electron. The energy of the electron beam, which is 3 to 30 kiloelectron volt, which is quite much, will eject the electron from the core energy level. The electron from the higher energy level like L shell will jump and will fill the core K shell electron vacant position. So during the transition from L shell into a K shell, electron will emit K alpha X-rays. The energy of the K alpha X-rays, if it is higher, then it will eject the electron which is present at higher energy level, and this ejected electron will be a OJ electron, and the process will be OJ process. So dear student, in a simple word, in OJ electron spectroscopy, electron gun is used to incident a stream of an highly energetic beam of electron on an atom, and that stream of highly energetic electron beam basically cause the emission of the core shell electron, and due to emission or removal of the core shell electron, higher energy electron usually jump into the vacant position of emitted core shell electron, and during the transition from higher energy level into a lower energy level, the electron emit characteristic X-rays. So these characteristic X-rays have quite higher energy, and when they interact with any electron having a less binding energy with the nucleus, then it will eject that electron, and that electron or that tertiary electron is known as OJ electron. So these electrons are basically detected in OJ electron spectroscopy, and on the basis of detection, on the basis of intensity and energy of the OJ electron, elemental and as well as compositional analysis of material surface is done. Now dear student, let's discuss that during OJ electron process how inner shell transition take place, how electron from a higher energy level jump into a lower energy level, and how the electron during the transition of electron from higher energy level to a lower energy level emit the Auger electron due to the interaction of the emitted photon or emitted X-rays during the transition from higher energy level into a lower energy level. Dear student, an atom has K, L, M, N, and so on shells. So these shells are basically known as energy levels. Every shell in atom has one or more subshells. These most commonly used subshells are S, P, D, F subshells. So dear student, please note that all the energy level shells and subshells are present around the nucleus of an atom. Every shell K, L, M, N, and so on in an atom is further divided into subshells S, P, D, F, etc. K shell has only one subshell, and that is 1s2. L shell has two subshell 2s2, 2p6, and M shell has three subshells 3s2, 3p6, 3d10. S subshell have maximum number of 2 electrons. P subshells in any shell have maximum number of 6 electrons. D subshell in any shell of an atom have possibly a maximum number of n electrons. F subshell in any atom have possibly maximum number of 14 electrons. So electrons are basically distributed in subshell of a shell, and the expected position of an electron in a subshell is determined by orbital. So the student, every subshell in an atom has orbital which determine the maximum probability of an electron present in a subshell. So if I conclude an atom has K, L, and M, and so on shells, every shell in an atom like K, L, and M, etc. shall have subshells like S, P, D, F. The maximum number of electrons present in S subshell of any atom is 2. Maximum number of electrons present in any shell in P subshell is 6. Maximum number of electrons present in D subshell is 10 in any shell of an atom, and similarly maximum number of possible electrons present in F shell is 14 in any atom. So as a whole, K shell of an atom have possibly maximum number of 2 electrons. L shell have maximum number of 8 electrons, whereas M shell have maximum number of 18 electrons. Every subshell in an atom has orbitals in it, and orbital basically determine the maximum number of probability of presence of electron in subshells. So dear student, now let explain the electron transition take place in Auger electron process, and due to electron transition, how an Auger electron is emitted from an atom during Auger Electron Spectroscopy. Dear student, an atom has a nucleus. Around a nucleus there are energy levels, and these energy levels are known as shells. The first energy level around the nucleus is known as K shell. Student, please do note that shell is basically a pathway which is followed by the electron around the nucleus. Shell is represented by a quantum number. So the first shell around the nucleus is known as K shell, which is further divided into subshell, and K shell has only one subshell. The term 1 represents first shell, S represent subshell, 2 represent the maximum number of possible electrons present in subshell. So the maximum number of possible electrons present in 1s2 subshell is 2. Dear student, please note that an atom please note that a subshell is further divided into an orbital, and according to Pauli exclusion principle, an orbital have a maximum number of 2 electrons with opposite spins, so that can accommodate only 2 electrons with opposite spins. So in K shell, the maximum number of electrons are 2, which are present in 1s2 subshells. Student, please note that subshell is, if we define a subshell is a pathway in which electrons move within the shell. So basically it is a path in which an electron move within a shell, whereas shell basically is a pathway in which the electron moved around a nucleus. The subshells are usually represented by momentum quantum number. And the maximum number of electrons can hold by a subshell depend on a type of subshell. So in a simple word, first shell around a nucleus in an atom is known as a K shell, and K shell is divided into one subshell, and it is 1s2 subshell. Second energy level around a nucleus of an atom is known as L shell. L shell in around a nucleus is further divided into 2 subshell. One subshell is known as 2s2 subshell, and second subshell is known as 2p6 subshells. So the maximum number of electron maximum number of electron in L shell of an atom is usually 8. 2s2 subshell has only one orbital, and it has a possibility of 2 electrons with different spin in one orbital of the 2s2 subshell. Whereas the 2p6 subshells have maximum number of 6 electrons, and these 6 electrons are present in 3 different orbitals with opposite spins. Third energy level around a nucleus is known as M energy level or M shell. M shell has a maximum possible number of electron 18, and it is further divided into three subshell. The first subshell of M shell is known as 3s2 subshell. The maximum number of electrons present in 3s2 subshell is 2, and it has only one orbital. The second subshell in M shell is known as 3p6 subshell. The 3p6 subshell is further divided into three orbitals, with each orbital having a separate electron with opposite spin. So the maximum number of electrons present in 3p6 subshell are 6. Third subshell in M shell is known as 3d10 subshell. Maximum number of electrons present in 3d10 subshell is 10. And this 3d10 subshell is further divided into 5 different orbitals, and these orbitals have maximum number of 2 electrons, each with a different spin. So the maximum number of electrons present in M shell is 18. So similarly, the number of subshell increases with increase in the number of shells in an atom. So now let's discuss that how, due to a transition of electron in this shell, Auger electron are emitted from an atom. So now consider the K shell as a core shell of an atom. So the core electron shell will have a maximum number of 2 electrons. Consider the schematic representation of an electron present in a core energy level. Okay, so for simplicity I am representing that the K shell with a 1 electron, though it is consist of number of 2 electrons. So basically, in order to understand the phenomenon, I'm just representing that the shell, only one side of the K shell with 1 electron. Okay? So this is the core electron present in a K shell. So now, in Auger electron spectroscopy, energetic beam of electron is fall on an electron which is present in a core shell. So this is the energetic stream or energetic beam of electron which is fall on the electron present in a core shell. Now, dear student, if the energy of the electrostatic beam of electron is higher than the binding energy of this core shell electron, then this electron will be ejected from an atom. In Auger electron spectroscopy, the beam of electron has an energy of 3 to 30 kilo electron volt, which is quite much. So it will easily eject the core electron from core K shell like this. Okay, and when the energetic beam of electron eject the core electron from core K shell, this will result into a creation of vacant position or vacancy in a K shell. So this K shell of an atom become unstable. So as a whole, the atomic structure become unstable. So in order to stabilize the atom, electron from higher energy level will jump into the vacant position of core K shell electron like this. So this electron from this higher energy level L shell will jump into a core K shell electron vacant position. So when this higher energy L shell electron jump into a core K vacant electron position, they will result into an emission of characteristic X-rays like this. Basically, characteristic X-rays are produced due to inner shell transition from a higher shell electron transition from a higher shell into a lower core energy shell will result into a transition of the characteristic X-rays. Please note that the emitted characteristic X-rays during the transition of higher energy electron into a lower energy electron is quite much. So this beam is quite intense. The characteristic X-rays have higher energies. So if this characteristic X-rays have a higher energy and if it is fall on any electron present in the higher energy level like this, then these characteristic X-rays will result into the ejection of the electron from these higher energy level. And the ejected electron, this one, is known as Auger electron, and this Auger electron is further analyzed by a detector to determine the composition and element present in the surface of the material. So if I conclude the electron transition which generate an Auger electron, it will be like this, that considered the electron present in a core energy level K shell, when incident beam of or incident stream of electron with higher energy around 3 to 30 kiloelectron volt fall on the core energy level electron, they will result into ejection of the core energy level electron from the atom. So when the core energy level electron is emitted from the atom, there will be a creation of vacancy. So the structure of atom become unstable. So in order to make an atom stable, higher energy level electron like L shell electron will jump into a core shell K electron valence position. So when higher energy level electron jump into a core energy level position of the core energy electron, then as a result it will emit higher energetic characteristic X-rays. And when these higher energetic characteristic X-rays interact with electron which is present at higher energy level, if the binding energy of the higher energy level electron is less than the characteristic X-rays, then they will result into emission of the higher energy level electron, and that emitted higher energy level electron is known as Auger electron. And the process of transition is known through which the Auger electron is emitted is known as Auger electron transition process. So now, dear student, interesting point to notice here during an electron transition and emission of Auger electron is the spectral line associated with Auger electrons. There may be different types of spectral lines associated with Auger electron emitted from atom, like KLL Auger electron spectrum line or KLM Auger electron spectrum line, etc. So, dear student, like if the high energetic beam of incident electron basically eject the core electron from M shell like this. So the higher energy level, if the L shell electron jump into a vacant position of the core K shell electron, then this the transition will cause the emission of characteristic excess. Now, if the emitted characteristic excess, this excess interact with any electron present in L shell somewhere here. Since you know that L shell have a maximum number of 8 electrons, so if this characteristic excess interact with L shell electron, and if the energy of this characteristic excess is higher than the L shell electron somewhere here, and it ejects the L shell electron, then the spectral line associated with such electron will be KLL Auger electron spectral line. Because the transition or the electron jump from L shell into a core shell, and similarly the electron in a form of Auger electron is also emitted from L shell. So the spectral line of the Auger electron will be known as KLL Auger electron spectral line. Similarly, if the L shell electron jump and fill the vacant position of core K shell, and it emit the characteristic excess, and if this characteristic excess eject the M shell electron as a Auger electron, then the spectral line associated with the electron which is Auger electron from M shell will be KLM spectral line, because the L represents the transition of electron from L shell into a core K shell, and due to transition of electron from L shell into a K shell, they emit K alpha X-rays, and those K alpha characteristic X-rays basically eject or emit the Auger electron from the M shell. So as a result, the spectral line associated with such Auger electron will be KLM spectral line. Dear student, we can say that the peak seen in the Auger electron spectrum in Auger electron spectroscopy is labeled according to the shelf involved in the movement of electrons. So basically the Auger electron spectroscopy represent a peak which is determined on the basis of the intensity and energy of the Auger electron. So since you know that Auger electron are produced or emitted due to a transitions between the shells of the electron and their characteristic excess, which basically removes the another electron, third electron from the shell. So due to the transitions of various shells, or transition of electron in various shells, the spectrum is labeled, and on the basis of energy of the labeled spectrum of different elements, you can basically determine the type of the element, and similarly also on the basis of intensity of the element you can determine the composition. You can determine the composition of the material present. So in a simple word, the peak seen in Auger electron spectroscopy is labeled according to the shell involved in the movement of electrons. For example, an Auger electron ejected from L or M shell could be labeled as KLL or KLM. So it will depend on the transition of the electron from higher energy level like L energy level into a core energy level like K energy level, or from higher to higher energy level, or from K to L energy level. So on the basis of that, the spectrum is labeled. The intensity of the peak depends on the amount of material present, while the peak position will determine the peak position is element dependent, will determine that what kind of element is present in material. So if I conclude, in Auger electron spectroscopy you observe the peak of emitted Auger electron. The emitted peak of Auger electron has intensity and position. The intensity of emitted peak of Auger electron demonstrate the amount of material present, while the position of the peak of the Auger electron in Auger electron spectrum determine the type of element present in the material. So as a whole, with Auger electron spectroscopy you determine the amount of material present and you determine the element present in a material. So in a simple word, with Auger electron spectroscopy you can determine the presence of element and as well as composition of the material. Dear student, Auger electron spectroscopy is a very in-depth characterization technique. So you can use it in a broad manner for analyzing the material surface, for analyzing the composition and elemental analysis of the material surface in a depth rate of 3 to 10 nanometer. So now let us briefly explain the different types of application of Auger electron spectroscopy. So where the Auger electron spectroscopy is used. First of all, in a simple word, Auger electron spectroscopy is a core technique of microelectronic industry. So usually in microelectronic industries, the substrate with a highly purity are used. So the Auger electron spectroscopy basically determines the average composition or average variation of composition if they are present on a substrate, and even a very compositional variation of the thin film. Similarly, Auger electron spectroscopy has different types of wide range of applications. So now let us discuss about few applications of Auger electron spectroscopy. Auger electron spectroscopy give us high resolution chemical imaging of thin film and coating. So basically it is a high resolution imaging process and it gives us a resolution about 100 angstrom. So in thin film coating, usually ultra thin films in a range of few micrometer are deposited. So basically Auger electron spectroscopy provide us an opportunity to give a high resolution chemical imaging of the material. So on the basis of the high resolution chemical imaging, we basically determine the chemical composition of the material. Auger electron spectroscopy is used in depth profiling. So this trend usually depth profiling is a profiling in which a material from the surface is removed and below the layer the composition of the material is analyzed by Auger electron spectroscopy. So basically with this technique we can basically determine the composition of the material below few layers of the material present. Like if you have coated a material as a whole, and if you are interested to analyze that what is the composition beneath the coated areas, the area of some small area of the material, of the coated material, is removed by a depth profiling method. Usually ion beam implantation or sputtering is used to remove some material from the surface, and that removed material, after that Auger electron spectroscopy is used up to a depth of 3 to 10 nanometer, and in that region the emitted Auger electron basically will give the information about elemental and chemical composition of the material below the layer. So this technique is most common in analysis of the material by using a depth profiling below the layer. Another application of Auger electron spectroscopy is that Auger electron spectroscopy identify if any particulate is present in a matter or in a material. Auger electron spectroscopy determine a presence of a dopant in a single crystal in a semiconductor industry. Auger electron spectroscopy also give us information about the contaminant present in the material. So due to this, Auger electron is very important technique in a semiconducting and microelectronic industry, because in microelectronic industry we need very pure single crystalline substrates materials. So in order to achieve a single crystalline pure substrate material with more than 99% purity, we need Auger electron spectroscopy to assess if there are any type of contaminant present. Apart from this, in semiconductor industries there are different ratios of P and N dopant in a material. So basically Auger electron spectroscopy can also determine what is the percentage of dopant material present in a parent material. So basically this technique basically give us information about the presence of any impurity on the sample surface in the depth range of 3 to 10 nanometer. This technique give us information about the presence of a percentage of dopant in a material, and apart from this technique give us information if there is any type of contaminant or particulate present on the surface of the matter. Student, Auger electron spectroscopy is highly sensitive process. It can determine the composition of any type of monolayer except hydrogen and helium. So basically the Auger electron spectroscopy is a very diverse technique. You can analyze any type of chemical composition or elemental analysis using Auger electron spectroscopy, but only two elements like hydrogen and helium you cannot determine their composition in Auger electron spectroscopy. Student, why you cannot get information about the helium or hydrogen presence in a material using Auger electron spectroscopy? Student, please note that Auger electron spectroscopy is a technique based on collection of Auger electron from a metal surface. So hydrogen has one electron in a K shell, whereas helium has two electrons in a K shell. This means that there is no L, M, N shells with additional electron which can basically which may jump into a lower energy level like K shell, and as a result they emit an characteristic X-rays which can basically eject the Auger electron from these atoms. So this means that due to a single shell in these elements or atoms, there is not a possibility of emission of Auger electron from hydrogen and helium atom. So on the basis of that, you cannot detect helium and hydrogen atom in Auger electron spectroscopy. Please note that another interesting fact of Auger electron is that with Auger electron spectroscopy you can determine the surface cleanliness, and also you can determine corrosion if it is present in thin films. Usually when you prepare a thin film in different types of vacuum based technique or by chemical solution based techniques, there is a possibility of different types of impurities which may be created by different ways. These impurities may be present on the surface of the material. So these can be determined only on the Auger electron spectroscopy basically tell us how much surface of our sample is clean. What is the ratio of cleanness of our sample? So basically the profile of Auger electron spectroscopy will tell us is there any kind of impurities present on the surface. So on the basis of that profile we can basically clean the surface of our material. Secondly, the corrosion is also an issue for different types of material. So Auger electron spectroscopy can also tell you about the percentage of corrosion present on the surface of thin film or on the surface of material. So basically this technique can give you an opportunity to produce highly pure material with better cleanliness and without corroded areas. So they can basically, this technique give you an information that how much your material is clean and how much your material is corroded. Auger electron spectroscopy can do compositional analysis of the surface region of the specimen by comparing with a standard sample of a known composition. So basically this technique give you information of a chemical composition of the material on the surface. The reason is that, dear student, the depth of Auger electron spectroscopy is in the range of 3 to 10 nanometer. So with this technique you can basically achieve compositional analysis in the range of 3 to 10 nanometer of the materials. Usually the data which you achieve in Auger electron spectroscopy, there is also a standard sample which has a certain composition. So the data which we achieve from the spectrum which we achieve from the Auger electron spectroscopy can be or may be compared with a standard sample. So on the basis of that you can basically determine that what kind of material is present in a sample, in the surface of the sample. Apart from the compositional analysis, Auger electron spectroscopy is also used to analyze different types of surface mediated reactions. If there are any kind of chemical reactions which are mediated, which are produced at the surface, Auger electron spectroscopy can also determine those chemical reactions. Some of the common chemical reactions which can be determined by Auger electron spectroscopy are sorptions, physical and chemical sorptions, catalysis, Auger electron spectroscopy can also determine dissolution precipitation. Auger electron spectroscopy can also determine the redox and photocatalytic reaction taking place on the surface of the material. Now, let's discuss that what does Auger electron spectroscopy provide to us? Why we basically use Auger electron spectroscopy. Please note that, as I have previously discussed, this is a very diverse technique. This technique gives us information about the chemical composition and as well as about the presence of an element in a material. This technique is limited, or this technique cannot be used to analyze the hydrogen and helium atom because they have only one shell, and Auger electron cannot be emitted from one shell. So now let's discuss what Auger electron spectroscopy can give us. Auger electron spectroscopy gives us the composition of the surface with very high resolution. Auger electron spectroscopy can also give us the secondary electron imaging. Auger electron spectroscopy provides a high magnification and visualization of the sample. So this means that with Auger electron spectroscopy we can basically analyze a composition of the material present at the surface with very high resolution, and also Auger electron spectroscopy can also provide us the secondary electron imaging, which can basically magnificently can visualize the sample surface. We can also do an elemental analysis by Auger electron spectroscopy by getting a spectra from the Auger electron spectroscope or spectrometer. So Auger electron spectroscopy basically can determine that what element are present and what is the quality, what is the quantity of the element present in a surface of the material with a penetration depth in the range of 3 to 10 nanometer. Auger electron spectroscopy, we can basically achieve high energy resolution spectra. We can also achieve imaging of the depth profiling by removing a layer from the sample surface and then analyze the material composition under that layer. So basically chemical state of some material are basically analyzed by Auger electron spectroscopy. Auger electron spectroscopy provides us the elemental imaging and mapping of the material. This technique can also determine about the two-dimensional elemental distribution on the surface of the matter. So basically, the image which we achieve from Auger electron spectroscopy is two-dimensional, and on the basis of the image we achieve from Auger electron spectroscopy, we can basically determine the overall elemental distribution in a certain range of the sample, certain range of the area of the sample in two-dimensional. Auger electron spectroscopy, basically we do sputter depth profiling can be done with Auger electron spectroscopy, and you can basically determine what is present beneath the surface of the sputtered area. Okay, so basically a layer of the sample is removed, and on the basis of this basically we reveal the composition of the thin films below the layer. Let's say if we coat a certain material, we coat a thin film on a certain material, and we want to know the composition of the material, then the thin film, some area of the thin film may be removed by using a sputtering, and beneath that Auger electron spectroscopy can be used to analyze the chemical composition of the material. So basically, Auger electron spectroscopy revealed the thin film and interfacial composition. Interfacial composition means that it is like when you deposit a thin film, there is a layer between a substrate and a thin film. So between the substrate and a thin film, you can basically determine what is the actual composition with which both the thin film and layer are connected. And this is done by Auger electron spectroscopy. Limitation of Auger electron spectroscopy. Limitation mean that where we can use the Auger electron spectroscopy. Auger electron spectroscopy, you cannot detect element with one shell, with only core K shell. This means that, the student, you cannot detect hydrogen and helium atoms with Auger electron spectroscopy. The student, why you cannot detect hydrogen and helium using Auger electron spectroscopy? The answer is quite simple. Helium and hydrogen atom have 1 and 2 electron in their K shell. So they have only one shell, and there are not other shells from which the transition may take place, from which the electron may jump into a lower K shell electron and emit X-rays, which basically interact with the electron present at a higher shell and remove it as an Auger electron. So that's the basic reason that Auger electron is limited to all elements, but it is not possible to do Auger electron spectroscopy for hydrogen and helium atom because they don't emit Auger electrons. Another drawback with Auger electron process or Auger electron spectroscopy is that this technique is destructive technique. So basically, if you want to analyze a depth profiling of a sample, if you want to analyze the chemical composition and elemental analysis below the deposited layer or at the interface of the thin film and a substrate, then it is quite difficult for Auger electron spectroscopy to do without sputtering some region or without sputtering of the surface of the material. So after removing some part of the material, you can basically do the depth analysis. You can do the depth compositional analysis below that layer in the range of 5 to 10 nanometer. So this means that Auger electron spectroscopy is a destructive technique. It damages the material which is under the analysis. Another drawback of Auger electron spectroscopy is that only small sample can be analyzed, and compatibility with vacuum is also an issue. So basically, with this technique, only a small region of a sample, only a small area of the sample is analyzed. And secondly, you have to check that whether the material which we want to analyze under the Auger electron spectroscopy is compatible to a high vacuum environment or not. So the sample compatibility and as well as high vacuum compatibility under the Auger electron spectroscopy are also the limitation in Auger electron spectroscopy techniques. They must be considered. And the other drawback or limitation of Auger electron spectroscopy, as I have previously discussed, Auger electron spectroscopy is a destructive technique. So basically, high energetic beam of electron when incident on a sample surface, it damages the sample surface because the intensity of the incident beam of electron is too much. And that's the reason Auger electron spectroscopy is a destructive technique for the sample. Another drawback with Auger electron spectroscopy is that this technique cannot be used for non-conducting material, or it is difficult to analyze a non-conducting material using Auger electron spectroscopy because the electron beam may cause a sample surface charging. Basically, sample is non-conducting, okay? When the electron beam fall on the sample surface, that electron beam cause a surface charging on the sample surface, which basically reflect again the incoming electron beam onto the surface of the surface. And due to this, it is quite difficult to analyze a non-conducting samples with Auger electron spectroscopy. So this means that when you are doing Auger electron spectroscopy, okay, there, if you obtain an image from Auger electron spectroscopy, you will see that there will be an anomalous contrast in Auger electron spectroscopy image because of the non-conducting specimen, and that is an indication of a presence of electric charges on the surface. The cause of the surface charging is usually due to the difference between the ambient electron and the ion flux on the surface of the material. That means the non-conducting material will basically create, when the electron beam fall on them, they will create charges on the surface of them. Basically, the surface will be charged, and the charges or electron will be at the surface of those material. And when the other beam continuously fall on the surface, they will basically deflect the charges of the beam, and which will cause a problem in analyzing the surface of the sample, and that give rise in anomalous contrast in Auger electron spectroscopic image or in Auger electron spectroscopic data. So that's the non-conducting material. It is quite difficult for Auger electron spectroscopy to assess the non-conducting material as compared to a conducting sample surface. Students, please note that Auger electron spectroscopy is used for element with lower atomic number because Auger electron yield is high, while Auger electron yield is less for high atomic number element. This is very important fact, that Auger electron are more easily emitted if the atomic number of an element is less, whereas it is difficult for Auger electron to be emitted from element with high atomic number. So this means that Auger electron spectroscopy is more useful for element with lower atomic number as well as compared to an element with a higher atomic number. This can be represented by a graph like this. Since you know that Auger electron are tertiary electrons, so when energetic beam of electron are incident on a K shell or core shell electron, that core shell electron is ejected. and an element from an electron from higher energy level like L shell will jump into a core K shell, and during transition of L shell electron into a core K shell, the K alpha X-rays will be ejected. Now, students, please note that this K alpha characteristic X-rays will interact with electron present at higher energy level, and it will easily knock out the electron from higher energy level if the energy of the characteristic X-rays is higher than the binding energy of the higher energy electron, and in this way the tertiary electron ejected is Auger electron. Now, if element have a lesser atomic number, then there will be a few shell like KLM shells. So when the energetic X electron beam fall on the inner core shell, the core K electron will be ejected and the electron from L shell will jump into a core K shell. So due to a transition from L to K shell, characteristic X-rays are emitted. Now, if an element have a higher number of shells like L, M, N, O, P, etc., then if the characteristic X-rays which is emitted during transition interact with M shell electron or with L shell electron, then electron will be ejected as a Auger electron. But on the way, since there are more shells, then Auger electron will again interact with different kind of electron present in the shells, and due to this there will be a difficulty, or there will be a less amount of Auger electron to be ejected from the atom with higher atomic number. In case if an atom have a lower atomic number, then there will be less shells, and the tertiary electron which is ejected due to K alpha X-rays will be easily ejected without interacting with other electron present in higher elements with higher shells, and in this way the ejected electron will be easily removed from an atom as an Auger electron. So this means that Auger electron are more and can easily be produced from an element with lower atomic number. Like this is a schematic representation. The red line basically indicates that the number of Auger electron released from elements with a lower atomic number is high, and it is decreasing when the atomic number of an atom is increased. It is contrast to the X-rays yield. An element with higher atomic number will have a higher X-ray generation as compared to an element with a lower atomic number. So this is also a limitation for Auger electron spectroscopy, that this technique is valid or is more useful with element having a lesser atomic number. Having atomic number it is more effective in elements having an atomic number in the range of 3 to 20. Though the Auger electrons are emitted even in the elements having a higher atomic number, but the rate of the emission of Auger electron will decrease with higher atomic number. Another drawback with Auger electron spectroscopy is detection limit. Auger electron spectroscopy can detect 0.1 to 1% of the monolayer, and 10 to the power minus 16 to 10 to the power minus 15 gram of material with a volume of 10 to the power 12 to 10 to the power 13 atom per centimeter square. So detection limit from which an Auger electron are emitted is quite less, and that's the reason the penetration depth of the electron is also very less. The sample destructive process use of focusing of electron beam can improve resolution. The high energy electron can destroy the sample. To limit the destruction, beam current density of greater than 1 milliampere per centimeter square should be used. So the problem with Auger electron spectroscopy is the destruction, because this is a destructive technique which damage the sample surface. So due to this, the current density around 1 milliampere per centimeter square is used in Auger electron spectroscopy. Processing steps involved in Auger electron spectroscopy. Students, please note that Auger electron spectroscopy is divided into three main steps. In first step, an core electron of an atom is removed. It is known as atomic ionization step. So initially, in first step of Auger electron spectroscopy, a core electron is removed from an atom. Student, please note that in Auger electron spectroscopy, a stream of electron is incident on a core shell of an atom. A core shell is usually a K shell of an atom. Student, please note that the energy of the incident beam is too much, and it is in the range of 3 to 30 kilo electron volt. So when such energetic beam of electron which is produced from the electron gun is fall on the surface of the sample, and if that energetic beam or stream of electron interact with an electron present in a core shell or core K shell, then the core K shell electron will be removed from an atom. The student, please note that the binding energy of the core K shell and as well as the energy of the incident beam electron both are important. If the binding energy of the core shell electron is higher than the incident beam energy, then incident beam cannot emit the electron from core shell. So in Auger electron process or in Auger emission electron spectroscopy, initially a high intensity beam of electron is incident on a sample surface, and the intensity and the energy of the incident beam is too much than the energy or binding energy of the core electron, and due to this the core electron is removed from the core K shell of an atom. This first step of removal of core shell electron is known as atomic ionization, which means that an atom is ionized because electron is removed from atom core K shell. After the removal of an electron from core K shell of an atom, the electron from a higher energy level will jump into a lower core K shell valence energy level. So when electron from higher energy level jump into a lower core K shell, the electron will release characteristic X-rays. These characteristic X-rays are released because the structure of the atom is destabilized, because the core K shell electron is removed by energetic electron beam. So the structure was destabilized. In order to relax the structure, electron from higher energy level will jump into a lower energy level. So this step is known as a relaxation process. So when the electron from a higher energy level jump into lower energy level, that electron will emit characteristic X-rays. And if the energy of the characteristic X-ray is higher than any electron present in an atom in higher shells, and if the characteristic X-rays interact with that electron, then characteristic X-rays will emit the electron from higher energy level, and that emitted electron is known as Auger electron. So dear student, in first step, the core electron is removed by application of highly energetic stream of electron. In second step of Auger electron spectroscopy, higher electron from higher energy level jump into a core K shell electron vacant position. It emit K alpha characteristic X-rays, and these characteristic X-rays interact with electron present at higher energy levels. And due to interaction of characteristic X-rays with electron at higher energy level, if the energy of the characteristic X-rays is higher than the binding energy of the electron present at higher energy level, then that characteristic X-rays will result into emission of the electron from higher energy level, and that electron is known as Auger electron. So in first step, a beam of electron is incident and a core electron is removed. In second step, transition between the higher and lower energy take place, which result into a generation of characteristic X-rays, and the characteristic X-rays emit the Auger electron from the atom. So in third step, the Auger electron which is emitted is analyzed. Okay, the Auger electron is analyzed by using a detector which is known as Auger detector. So these are the three main steps. First step is known as atomic ionization. Atomic ionization result into when a high energetic beam of electron or stream of electron interact with a core K shell electron, it emits the electron, which result into atomic ionization and destabilization of structure. Second step of Auger electron spectroscopy is a relaxation. High energy electron jump into a lower energy electron and result into an emission of the characteristic X-rays. And third step is the analysis of the Auger electron. So when the characteristic X-rays are released, these characteristic X-rays interact with any electron which is present at a higher energy level, and if the energy characteristic X-rays is higher than the binding energy of the electron present in higher energy level, then high energy electron will be emitted, which will be known as an Auger electron. So in third step, the emitted Auger electron is basically analyzed by using detector. So any conclusion? Auger electron spectroscopy consists of two steps. One is known as atomic ionization. Second step is known as atomic relaxation and Auger electron emission. And third step is known as detection of the Auger electron by using different kind of detector used in Auger electron spectroscopy. Dear student, let us discuss about the essential component which are present in Auger electron spectroscope. Auger electron spectroscope is a quite diverse instrument. So let's discuss that what are the key part or what are the key component present in Auger electron spectroscope. That Auger electron spectroscopy is done under a vacuum. So this schematic represent the Auger electron spectroscope chamber. This chamber of the Auger electron spectroscope chamber is evacuated by a vacuum pump associated or attached with a chamber of Auger electron spectroscope. Dear student, please note that the energy of the Auger electron is around 50 to 3 kilo electron volt. This means that when an energetic beam from electron gun interacts with a sample surface, the sample emits the Auger electron, and these Auger electrons have an energy of 50 electron volt to 3 kilo electron volt. So dear student, please note that this range of energy 50 electron volt to 3 kilo electron volt is basically in solid material is limited to a short mean free path. Mean free path is an average distance between two particles or two collides like Auger electrons. So this means that it is quite difficult to emit Auger electron from longer depth. So that's the reason that Auger electrons are usually ejected from a sample surface in the range of 3 to 10 nanometer, whereas the average depth from which Auger electron is emitted from the sample surface is 5 nanometer. So this means that the Auger electrons are very sensitive because of their shorter mean free path. That's the reason high vacuum chambers are very important because the emitted Auger electron have less energy and they have shorter mean free path. When they emit from the sample surface, then these Auger electrons may interact with different kind of gases present in the Auger electron chamber, and that's why they cannot be easily detected then with detector. So due to this, reaction chamber of Auger electron spectroscope is 800 under ultra high vacuum. Usually vacuum is used in Auger electron spectroscope is in the range of 10 raised to power minus 9 torr. Student, typically Auger electron spectroscope is an instrument which operates at a pressure of 10 raised to power minus 9 torr. This is important because the gas in a sample chamber or Auger electron chamber can impede the transfer of Auger electron from the material surface to a detector, because the energy of the Auger electron is short, is less, like 50 electron volt to 3 kilo electron volt. So that means that if the Auger electron are emitted from the sample surface, then if there is a presence of gas, then the gas in the chamber, then the gas may impede the flow of the Auger electron from the reaction chamber from a sample surface to a detector, and on the basis of that we can basically detect a very small amount of Auger electron from the sample surface. So ultra high vacuum is very important, and that ultra high vacuum basically counts the efficiency of the detector, is responsible for the efficiency of the emission of the Auger electron. Material surface to be usually the surface of the material is also highly reactive, okay, and so the ultra high vacuum is needed to prevent the contamination of or absorption of the gases onto the material surface. So like when the sample surface from which the Auger electron are emitted, so the surface is usually very sensitive. So that's the reason the evacuation of the sample surface is evacuation of the chamber, this whole chamber of the Auger electron spectroscope is very important, because if the sample surface is not, if the chamber is not evacuated, the gas, if it is present inside Auger electron spectroscope, will be absorbed onto the surface of the sample, and that can decrease the efficiency of Auger electron spectroscope. So vacuum is very important in Auger electron spectroscope, and vacuum is in the range of 10⁻⁹ torr. So this is basically this rectangular one shape represent a Auger electron spectroscope chamber, and whereas the circular one basically represent the high vacuum pumps, which ultra vacuum pumps, which are attached with the Auger electron chamber. Inside the Auger electron chamber there is a sample holder. Okay, this is a specimen holder. So the specimen holder is a holder on which a sample is placed, a sample from which an Auger we want to generate Auger electron is placed on a specimen holder like this. This is a sample which is placed on, or specimen which is placed on the specimen holder. So dear student, please note that specimen holder used in Auger electron spectroscopy must have a higher melting point, because there may be a creation of a temperature inside the Auger electron spectroscope. So the high melting temperature specimen holder are used. The specimen holder melting temperature must be higher than the specimen or than the sample which is under observation for Auger electron spectroscopy. So the specimen or a sample which is under observation or from which we want to generate Auger electron is placed on a specimen holder in Auger electron spectroscope. Auger electron spectroscope has electron gun inside the Auger electron spectroscope holder. Student, please note that inside the Auger electron spectroscope chamber there is electron gun. I have some other lectures on electron gun, and you can basically follow those lectures about the construction, that how the electron gun is constructed and how what are the different components of the electron gun. So basically electron gun is an instrument which emit a highly energetic stream or a beam of electron. Okay, and these electron beam have higher energies. The energy range is around 30 kilo electron volt to even more. So that the stream of the electron beam from the electron gun will be incident on a sample holder or on a specimen. Dear student, please note that Auger electron spectroscopy uses a focused electron beam to stimulate the material surface. So the electron gun will incident a focused electron beam onto the surface of the specimen. Okay, and the electron beam basically will have a higher energy, and that higher energy of the electron beam or stream will interact with the sample surface, and only Auger electron will be emitted from the sample surface in the range of 3 to 10 nanometer. However, the average penetration depth of the Auger electron emission is in the range of 5 nanometer. So when the stream of electron beam or incident on a specimen surface, energetic beam of stream of electron will basically produce or emit Auger electron from sample surface in the range of 3 to 10 nanometer. Dear student, please note that usually the electron gun used in Auger electron spectroscopy have a filament, and which is connected with a different types of cathodes, and the filament is basically heated, and the thermionic emission of the filament basically cause a heat to the cathode, and cathode emit a stream of electron, and which is the stream of electron which is accelerated by different types of grid present in electron gun, and that stream of electron has a very high energy. And when the high energy stream of electron incident on a specimen surface, the Auger electron will emit only from in the range of 3 to 10 nanometer. Auger electron spectroscope have an electron detector. It is also known as electron energy analyzer. So basically the work of the electron energy analyzer or electron detector is to detect the Auger electron which are emitted from the specimen surface, and the Auger electron are directed onto the electron detector, and electron detector then detect and count the number of Auger electron emitted, and on the basis of intensity of the Auger electron detected, the elemental and compositional analysis is done. So dear student, the electron energy analyzer are usually based on cylindrical mirror analyzer, and that detector has proven to have a higher efficiency and good energy resolution. So basically they are usually in Auger electron spectroscope, the electron detectors are usually cylindrical in shape. They are cylindrical mirror analyzer with higher efficiency, because efficiency is very important in Auger electron spectroscopy. Since you know that the Auger electron emitted from the sample surface is very sensitive, they have less energy, and the transformation of Auger electron is also an issue, and then the detection of the electron is also an issue, because the efficiency of detecting the low energy Auger electron require a special kind of Auger electron detector. So the cylindrical mirror shape Auger electron analyzer or detector is developed to detect the low energy Auger electrons. So you can basically understand the structure and design of the cylindrical mirror Auger electron analyzer in my other lectures. So watch those lectures for understanding the internal design, that what is the internal design of the cylindrical mirror shape Auger electron detector. So in a simple word, Auger electron machine or Auger electron spectroscope consists of a chamber which is highly evacuated, and the vacuum is in the range of 10 to the power minus 9 torr in Auger electron spectroscope chamber. Auger electron spectroscope chamber has a specimen holder. The specimen or a sample is placed on a specimen holder. Electron beam gun is present in Auger electron spectroscope. Electron gun basically eject a stream of electron, emit a stream of electron, and incident stream of electron onto a surface of a specimen. And when the stream of electron is incident onto the surface of the specimen, the Auger electrons in a penetration depth of 3 to 10 nanometer are emitted from the specimen surface, and then these emitted Auger electron are detected by electron detector. Most commonly used electron detector in Auger electron spectroscope is known as CMA analyzer or cylindrical mirror analyzer. Another essential component or additional component in Auger electron spectroscope is known as ion gun. Ion gun in Auger electron spectroscope play a very important role. The ion gun uses a focused beam of ions. Okay, that's basically they used a focused beam of ionized gas. Usually it is argon onto a sample surface, and that the incident ion or gas molecules onto the sample surface basically cause a cleanness of the sample surface. Secondly, the ion gun has another important role if you are doing to do Auger electron spectroscopy in depth profiling or underneath the layer which is placed on the sample surface. Then a stream of the ion beam is basically incident onto a sample surface, and that stream of ion beam with higher energy remove some part of the sample surface or the layer of the sample, and after that the beneath the layer or beneath the broken part of the sample surface, the Auger electron spectroscopy is done to understand the chemical composition of the material beneath the layer of the sample. So basically this ion gun is very important in Auger electron spectroscope. First, the ion gun remove the presence of any kind of contamination on the sample surface. The second role of ion gun is to do the depth profiling of the sample. So dear student, if I conclude the role of the ion gun basically used a focus beam of ionized gas. Usually it is argon, and that focus beam is used on the sample surface to clean off the specimen surface. Often these contaminants usually they are present on the sample surface, so the ion gun remove those contaminants from the sample surface. As the Auger electron spectroscopy come only on a few atomic monolayer, a material surface may absorb as different kind of gases. So basically the Auger electron are very sensitive. So in order to get an Auger electron from specimen, the role of the ion gun is very important, and these ion guns remove the physically absorbed specimen if they are specifically absorbed gases if they are present on the surface of the specimen. Secondly, the ion gun basically is also used for depth profiling, okay, across the sample surface to document the compositional changes across the material surface. So basically the ion gun is also used across the whole specimen surface in order to check that what is the variation of the composition across the whole surface, and this analysis is basically known as a depth profiling. And in the depth profiling usually the sputtering is done, okay. The ion beam are basically incident on the sample surface. The beam have higher energy, they sputter the sample surface at a different point, and then by doing Auger electron spectroscopy you can check the composition varying across the sample surface, and on the basis of that you can have an idea that what is the average variation of the composition across the specimen. Student, please note that let's explain this how the ion gun basically interact and cause the cleanness of the sample surface or depth profiling of the surface. Usually, the student, the ion gun has very highly energetic beam of ion. These are usually based on ionized argon molecules. So when these interact with a sample surface, the ion gun usually is rostered over a whole sample surface. So if there are any type of absorbed species of gases of the reaction chamber on the specimen surface, then these absorbed gases will be removed. Secondly, if you want to do a depth profiling, if you want to do an average variation of composition over the sample surface, so the energy of the ion gun is further increased, and that will cause a sputtering of the specimen over the different parts. And by doing Auger electron spectroscopy over those sputtered areas, you can have an idea of composition of the specimen. So now, dear student, let's explain that how Auger electron spectroscopy is done. In Auger electron spectroscopy, a high energetic beam of electron is emitted from the electron gun, and it is incident onto the surface of the specimen. This is a representation of a highly energetic beam of electron which are incidenting on the surface of the specimen. These highly energetic beam of electron which incident on a specimen surface will basically emit Auger electron from a specimen or from a sample surface. These Auger electron will be emitted in a range of 3 to 10 nanometer, whereas the average depth rate from which an Auger electron can be emitted is around 5 nanometer. So, the energetic beam of electron incident on a sample surface, and that energetic beam of electron emit the Auger electron from the sample surface, and the emitted electron are transferred onto the electron detector or Auger electron detector. So on the basis of that, we basically have an idea of the sample composition, and we have an idea about the presence of different element in Auger electron spectroscope. Okay, these students, please note that the Auger electron detector is connected with a voltage supply and also with a data acquisition systems. Okay, usually a voltage supply basically vary, and it's on and multiply basically it's the voltage supply vary when the Auger electron are basically detected at the electron detector, and electron detector also multiply the intensity of Auger electron, which is then connected with data acquisition, and after the data acquisition, basically we can have an information about the detected Auger electron in Auger electron spectroscope. So if I simply conclude the Auger electron spectroscopy, the student, please note that Auger electron spectroscope consists of a reaction of a Auger electron chamber. The Auger electron chamber is highly evacuated by a vacuum pump. The vacuum present is in the range of 10⁻⁻19 torr. The Auger electron spectroscope have a specimen holder, and a specimen holder is a holder which hold the Auger hold the specimen on the which hold specimen on it. Specimen is placed on a specimen holder. The student, there in some Auger electron spectroscope there may be present shutter. Shutter will open and close in order to control the emission of Auger electron. So the Auger electron spectroscope has an electron gun and ion guns. The role of the ion gun is to clean the sample surface. Okay, the incidentally highly energetic beam of ion gun basically are emitted and they are incident onto the surface of the sample. So when the stream or beam of ion with higher energy is incident on the sample of surface, they basically remove the physical absorbed gases if they are present on a specimen surface. Please note that Auger electron spectroscopy is a surface sensitive technique. The Auger electron can only be emitted up to a very small depth, around 3 to 10 nanometer. So in order to get the Auger electron efficiently, the ion gun basically remove the physically absorbed gases if they are present on a specimen surface. And at advanced level, if you want to do a compositional variation over the sample surface, then the ion beam basically is incident on a different part and sputter the sample surface over the different areas. And on the basis of doing Auger electron spectroscopy, you can get or you can have an overview of compositional variation over the different areas of the specimen. So ion gun in Auger electron spectroscope clean the specimen surface, and it's also cause a sputtering for depth profiling of sample surface. The Auger electron spectroscope has an electron gun. Electron gun is a device which liberate or which emit a stream of the electron. These stream of the electron when fall onto the sample surface, the stream of the electron basically generate an Auger electron. These Auger electrons are detected by Auger electron detector, and it is known as cylindrical mirror analyzer, which is an advanced Auger electron detector. The detector is also attached with a sweep voltage supply system to analyze the variation of voltage caused by the Auger electron. And secondly, the electron detector of Auger electron spectroscope is connected with data acquisition systems, and data acquisition system basically collect the overall data of the incident Auger electron on Auger electron detector. So on the basis of that, you can have a Auger electron profile, and on the basis of this you can have an idea of composition and as well as elemental analysis of the material present in a sample. So this is just an overview of Auger electron spectroscope. So dear student, thank you for watching this lecture. I hope you have understand all essential type of parameters, all types of properties, physical, chemical and internal designing of the Auger electron spectroscope. If you have any question, kindly you can share your question in comment section. So thank you for watching this lecture.